Okay, so I'd like to officially welcome everybody to the November Indicator of Behavior Working Group for the Open Cybersecurity Alliance. I'm your chair and host, Charlie Frick, over at Johns Hopkins Applied Physics Laboratory. I see we have a few folks coming in, but today I'll be very happy to share with everyone, along with, after this meeting, we'll post the YouTube recording as soon as I have the link. And for those that aren't able to join in real time, but I'll share a few bits of news and development. And then we're gonna have a pretty interesting tech talk today on streaming graphs and analytics with that using the Quine capability. Hopefully I said everything correctly, gentlemen. I don't know if it's Keen instead of Quine. Forgive me if I'm mispronouncing the product.
Nope, Quine is good. Quine is good.
All right. So normally we'll do a round of new introductions, but I believe mostly our new faces here are the folks from Quine. But if there's anybody brand new to the working group that'd like to introduce themselves, I'll give you a moment to say hello.
Hey, I'm Daniel Selick. I work with Swimlane. So glad to be here.
Fantastic. And
I'm Blake Lone Wiley, and I also work with Daniel and with Swimlane as well. We're on the same team.
Awesome. I probably want to bother you guys on a completely different topic sometime later.
Awesome. Great.
But glad to have you here. So I thought I'd start with some high-level news. As I know we've been talking about for our last few meetings, we've been working with the Open Cybersecurity Alliance to have this working group transitioned to what's called a sub-project. Our main reason for that is due to the bylaws of the OCA. A working group is only allowed to post documents to the OCA GitHub site, whereas a sub-project is allowed to post code. And through our work with CISA, APL has built a small little Python script that can translate any STIX 2.1 bundle into a Neo4j database. And we're very interested in open sourcing and releasing that to the public and doing that through this working group. So the good news to share is we have secured a majority vote from the management of the OCA to allow us to transition, but we do have to still wait for the vote to close, which will be, I believe, next Monday, after which we can then stand up the repository for that project and share that program out with everyone. And so for anybody that likes using graph manipulation for STIX data, it's a handy little tool for doing some quick research on a kind of plain vanilla Neo4j standup. But we found it very useful for our behavior research here at the lab, as we've been looking at some more complex bundles and sample query types. So just good news. And next week, we should be seeing some announcements on Slack, email, and LinkedIn to kind of help promote it. And very much looking forward to getting that out there to the community. We'll have some open discussion towards the end of the meeting, but just wanted to see if there are any questions on the transition to the sub-project. I know it's really a bit more of managerial side of things, but I want to open up the floor if anyone had a question. Excellent. Then I'm happy to let us dive deep right into the technical topic. Today, very happy to have some representatives from ThatDot here who have an interesting capability for streaming graphs called Quine that they're going to take us through some scenarios. And when I sat down with Alan and Robert and company to take a look at this, some of their examples I thought fit very well. If you've looked at some of the prototypes we've done in the reference implementation bundle of the type of analytics that we're searching and the sequence and patterns for detection and correlations, some of the work they're doing, I think, dovetails very nicely. So I'm excited today to have ThatDot here, and I'll hand the microphone over. So guys, if you'd like to take the reins, I'll be quiet and let you talk. And some, Robert, yeah, I think you're muted.
Sorry. Thank you so much. So thanks. I've been coming to the meetings for about a year. And so really appreciate this opportunity to share a little more in depth some of the things we're working on, because I think a lot of the concepts that we are bringing to market with our open source project are very well aligned with the technology and the kind of solutions that you folks have been working on. So I'll start with a quick introduction to who is that dot in Quine. And then Alan, if you could be prepared to bring up a demo, that'd be great.
Sure.
Fantastic. So Quine is Quine.io. It's an open source project. The company behind it, where we work, this technology actually started about 8 years ago. Our founder, Ryan Wright, developed the technology on his own for about 2.5, 3 years, and then was able to pull it into a DARPA program called Transparent Computing. So he was a principal investigator at a research lab. The Transparent Computing program had an objective of finding advanced persistent threats in large-scale networks. So finding the real needles in the haystack and finding them reliably and with very, very few false positives, if possible, was the grand objective. He was able to pull this technology he had developed into the program and essentially develop it over 4 years in that program and then extract it as the IP that that and the Quine open source community are now built upon. And so what is Quine? It's a streaming graph. And by that, it means that we apply a graph data model to data as it's ingested. And then we use that data instead of in a traditional database. We've taken the graph data model and melded it with an Akka-based event stream processing platform. And so it allows us to now bring in data as shown in the little diagram here, bring in data from multiple sources, which actually should be expanded here. We build that into a graph data structure. And so this solves an awful lot of data engineering problems, like how do we handle out of order data and data joins and time windows and all the things that come along with that. We mitigate all those issues by using a graph structure. And then we apply what we call standing queries, which are queries that live in the data. And so instead of the traditional database approach where we bring data in, put it in a database, then pull out a batch of it and apply queries against that batch, we actually put the queries in the data structure so that as new data arrives, it passes through or filters through the queries upon arrival. And so this allows us to take streams of events, build a graph, find patterns in that data in real time, and then generate events whenever we find that pattern. And so there's all kinds of interesting documentation out here. One of the things that we think we were especially clever.
Hey, Robert,
with,
we have a question out in the chat.
Sure.
Jason was wondering is Akka required for Quine's functionality or optional, just because Akka no longer is open source? He was curious.
Yes, so great question. We've actually been getting that from the community quite a bit. So we have incorporated Akka into our technology. We are on an older version that is not subject to the current revision in their licensing scheme. But yes, we do utilize Akka within the technology stack, but not the version that is currently under the new changed licensing schema. Good question. We actually have there's a Slack channel available. If you see the little icon up here, top right, I believe that's it may even have its own thread in there now. I think it's under either a general or its own thread. One of the things we did that we thought was kind of clever was we came up with this idea of recipes, and these are actually contributed by community members. And so these are example configurations of Quine to do different things. For example, Alan, the solution architect on the line here, built this recipe to look for patterns in authentication attempts and registrations that look like brute force attacks, various kinds of brute force attacks, password spraying being the most prominent one that we use as the demo. And so these are all examples that you can download, run a line of, you can do a quick command in your terminal window, as Alan will show us in a moment, and it will actually configure a downloaded version of Quine for this use case. And in this case, it actually refers out to some data as well, so that you can actually see it work. And this is a great way for people that are interested in learning about how we ingest data, how we form the graph, how we execute standing queries. Each of these recipes is an example of those 3 operations. And so it's a nice little skeleton for folks that are looking to experiment with it. All right, without further ado, I'm going to bring Alan into the mix here. He's much more proficient in the language that you guys all speak in the security space, and I think you'll enjoy the demo.
All right, thank you. So just to begin with, this is an example of a recipe. Recipes are sort of reusable configurations, canned configurations for pulling from data sources and operating on the data. The reality is that they're really used as models for what our users will do. The majority of configuration in runtime and production is done through our API. So everything that we're doing here can and is done programmatically. In this case, we have 3 important components: the ingest stream, which defines what are the sources, and then how do we shape those sources using standard OpenCipher. So, the language that was invented by Neo4j and then open sourced, and it eventually will be GQL once that gets standardized. In this case, we are pulling in data from a Kafka source with endpoint topic, and then another one with the network topic. So effectively what we're doing is we're simulating the case where we have XDR data from endpoints and then network data from some network monitoring device. And we take that data and we bring forth nodes and assign properties to them, so on and so forth. The other important part is the pattern matching, where we're looking for a case where an element will write data, a different element will read that data and then delete it and then send it off. So we're looking at a data exfil, a simple data exfil situation. And the last part is what defines the output. And the output goes to another Kafka topic. So what I'm going to do is I will start Zookeeper, because I have not updated the Kafka config to use its own internal orchestrator. Oop. Zookeeper. Oh, yes, it is. So why are you complaining? Yes. Seriously?
We're all no strangers to the demo gods.
Yeah, it's so funny because I literally ran this 2 minutes ago without issue. And it's all Kafka. Oh, because I am doing Kafka server and I want to do a Zookeeper. There we go. So there's Zookeeper. And then there is Kafka server. And then we'll run the console consumer because we'll see all the outputs from our standing query. So now what I'll do is I will simulate. Yes. Okay. So it's generating the endpoint and the network data, and then it passed it over to Kafka. So we have it there. So now what we'll do is we will just start Quine, which can be run either from a jar file or as a Docker image. No real difference there. So what you see here is that we're ingesting the endpoint data, we're ingesting the network data, and we're looking for something that matches our standing query, and we haven't found anything yet. So what I can begin with is something simple in our UI where I can show one of each element type. Again, this is standard Cypher, so you can actually use this query in Neo4j or memgraph, tygraph, or whatever. A couple of things to note. Whereas GraphDBs are optimized for ad hoc querying, really what we're optimized for is doing these matches in real time at rate. We just finished testing where we were able to pull in 1.2 something million records per second while running 4 or 5 standing queries and getting output from them. We're working on getting the hardware from Google, from GCP, to test 10 million records per second. So we're entirely focused on that. Now you'll see that we did have a match to our standing query. So as a result, that match was shot over to Kafka, and this is what that match looks like. And so I will just copy it and throw it in here. And we'll see that the graph that we get will include these node types. So from the raw data, we generated representations of each process, of communications, so read, write, send, receive, of actual endpoints, of files, and then of protocols. So I'll take that endpoint, or excuse me, that output that was received. And one of the neat things here is, and I apologize for saying neat, one of the cool things here is that rather than having some sort of a trigger against inferred behaviors, right? Whenever you're operating on metrics, everything's inferred. Going back to the Ethernet days, if you were above 30% bandwidth utilization, you'd see a lot of collisions. So the rise in collisions, and I'm sorry that I went old school there, but that's a really easy one. The rise in percentage of collisions was an indicator of bandwidth utilization, and we could infer that. And obviously this was before MIB2, if in octets, if at octets, where you can measure that. But that's sort of our position here, which is that rather than operating on inferred behaviors, we can match something that is intuitive, which is watching a process or a series of events happen and figuring out what happened as a result of this. So just looking at the alert, we see that there was a process Excel that wrote something, specifically this miscellaneous data in a temp file, and then this other process, NT-clean, read the file, sent the file somewhere, and then deleted the file. How do we know that that's the proper order? Well, again, because we're ingesting these, we're able to do interesting things. For example, I can say, okay, show me a timeline of events. There are none yet, because we're not being sent a timeline of events, we're being sent log events that we then take and use the properties to build these things dynamically at rate. So I can say, okay, create a timeline of events. All I've done here is run a query where I'm doing this matching, and then I'm ordering it by the time, and then doing a collect and creating the timeline. So we can see that from this file perspective, we first had this write operation, then we had this read operation, then we had the delete operation from the file perspective. If we were to do the same thing from the process perspective, then we would actually see something interesting. Oh, actually, I'm sorry, I didn't enable that one yet. What we would see is that from the process perspective, it would see the read followed by the send, followed by the delete, right? So by combining multiple sources in parallel, we're able to see a timeline of the events end to end. That's interesting, but we still don't really understand what it is that happened here. I mean, we know that this data was sent out, but how did that happen? And we can figure that out by using simple queries. Now, everything that I'm doing is based in the recipe, right? So we have this third component that I mentioned, which are quick queries. Generally, the UI is an exploratory UI, so we use it to model data for demos like this, and quick queries are really representative of what we would want to do programmatically in a NOC or a SOC, or a financial operations center, because that's another vertical that we focus on a lot. And so, for example, we have this quick query that can only be run on processes, and it basically says match that process where you have an event of type read. Okay, so when I'm right-hand clicking, that's what you're seeing here. And really, what we would expect is that we send this alert to Kafka, to Kinesis, to a JSON file, to a WebSocket, to wherever. And in the SOC, that gets used by whatever the existing tooling is, right? So we're a part of the ETL functionality, we're part of the pipeline. We actually are looking to build the business logic into these queries to make it easier for whoever is receiving these events to do something. So I go to this process Excel and I can say, okay, what was it started by? It was started by Outlook. This dotted arrow means that there's actually nodes in between these two nodes, these processes. I'm showing an example of a query with this logical relationship that lets you walk the nodes and edges. So I'm going to take a step back here and say that one of the massive differentiators between a streaming graph and a graph DB is that we intend to operate on data in motion and to do it at line speed. And to do it by keeping these active nodes in memory, we persist nodes to a backend like a Cassandra or RocksDB or MapDB, but the nodes that are active stay persisted in memory, and we identify them using a function that we call ID from, which is effectively a way of creating a deterministic index based on properties of the node. So if I wanted to search for a process named Excel, I could search for a process node with a property, the name of the process equals Excel, but that's slow. That's probably one of our worst choices in terms of searching through data. And unfortunately, that's very typical for graph DBs because that's how they're intended to be used. They're not time critical or time sensitive. In our case, when we create the node, we identify it when you create the recipes using something that is intuitive to identify it by. So for example, process, we create it by saying ID from that PID. The PID is the process ID field that we ingested and created as a property. So it is a property within the process, right? So if we hover over, we see the ID is Excel. So in this case, the process ID is Excel. In some cases, you'd see a process ID of a number because it doesn't get translated to a process. It's based on the source data. But what that means is if I wanted to find this process quickly, I would say match N, where ID of N is ID from Excel. And we generate that deterministic index and then are able to find that given node almost instantaneously. We're talking nanoseconds because, again, nodes and edges in memory, that's a really nice mapping. It's very easy to traverse nodes and edges very quickly. So if I were instead to expand this node, I would see that that event that launched Excel was a spawn event from Outlook. It launched Excel. Let's just lock these in place. And if I were to expand Excel, I would see that I have a bunch of these send and read events. That's interesting. Some write events. But let's look at these receive events because we can kind of guess that if Outlook is spawning Excel, that probably means that you received an email that had some form of a macro that allowed that to be spawned. I'll start with this write event because the write event we know is going to follow that receive and read event. But I'm doing it because, again, we have these really interesting relationships, right? Outlook wrote this spreadsheet, spawned Excel, Excel read the spreadsheet, and then wrote this temp file. Okay, let's look at these receive events. Okay, so we receive something from that IP address and port, and we receive something from that IP address and port. Something interesting here, right? 10.1.2.195, 10.1.2.195. So we probably received a macro from there, and we can drill down further and look into these other receive events and see what the file is. But at least now we know the source, right? So we can take some action. Everything I'm doing here is manual based on intuitive experience, my experience working in NOC and SOCs and working with security organizations. But because we're representing each of these events in this graph structure, and graphs are built to represent not just the nodes, but the relationships, what caused the creation of the nodes or altering the nodes or the rolling out of relationships, you can translate that intuitive or experiential set of filters in your brain to simple Cypher queries, right? So getting this alert, probably I would have a Cypher query that would say, okay, well, what wrote that event, and then what spawned that process that wrote the event, and walk that whole path. But even without that, you can see how easy it is for me to then see, okay, here is where that macro came from. Let's look at this. So we're seeing that there is some sort of behavior going on, right? So we're seeing that the send event to this zombie then uses a get event to a web server to actually place that data there. So it looks innocuous, right? Nobody worries about the port 80 traffic, especially gets versus like a put or delete or something that's impactful. So you can see how walking through these events, we can intuitively, just based on how we're creating the nodes and the relationships, figure out the entire path of how the exfil happened. But what's interesting here is that we're doing it in real time, right? So this isn't the case where you find out that something was exfilled a week later and then spend a month trying to pull data into Splunk and then map it together. And by the way, pay millions of dollars for the Splunk add-ons. Splunk has been a pain in my butt for years, so I'm sorry, I'm a little bitter. But it happens in real time here, right? So we get the alert that this pattern that we know is a bad one, right? What is the bad one? Well, we see an element write data, a different element read the data, then delete the data after sending the data, right? And we're able to set the timeframes of when that happens. What's the order that we expect this to happen? This is something we intuitively know is an attack. We could do the same thing, for example, for log4j, right? We know how that works. We know that there would be a call in the event to some external source. Well, we could build that same graph and look for it in real time and then take action on it. So I'm going to take a beat here and just make sure that I get really excited, and Rob tells me to slow down and to let other people ask questions and talk, but we're very excited about what we do. So please, any questions?
So just one thing to throw out there, Jason Kiersted from IBM had to unfortunately duck out, but is probably going to follow up in a little bit, see some interesting ways to tie this in with Kestrel threat hunting language.
Yes.
And some cases where we could kind of take that approach towards this. Also, a quick disclaimer, we here at the IRB Working Group have nothing but love for our brethren from Splunk, if any are on the call today.
Apologies.
All good, all good.
Yeah, so we've been looking at Kestrel. It's phenomenal because it is like Stix 2.1. It is very graphy, and the beauty of Kestrel is that it provides standardized notation. So you'll see here that we had to derive what each of these pieces were and then write our mappings ourselves. Kestrel is a beautiful thing because instead of saying, look for whatever you happen to call the process, it's defined in Kestrel. So the way that we see it is that we'll work on Kestrel to Cipher mapping, because it makes sense, or Cipher to Kestrel. I mean, we both will figure that out, but it means that these recipes become very reusable, and the standing queries become reusable. They get to be shared amongst people that use Kestrel and Cipher, whoever it happens, whichever Cipher implementation you happen to use.
And not to put words in your mouth, but as I see this, I'll confess my own bias. I tend to have SOAR on the brain a lot of times.
Yes.
But I definitely see this as naturally, folding into an orchestration platform of some sort, start taking certain actions on observed patterns. Would that be one of your main use cases, I would think? Or
Yep, absolutely. So that is one
if
of the
only we
beauty-
had SOAR vendors on this call right now.
Well, that's the beauty of Kestrel. It allows us, based on a standardized language, to then send something to a SOAR and have the SOAR language determine which paths to take. We're very big fans of SOARs, because the whole point of creating these sets of relationships is for them to be intuitive, and SOARs are by definition supposed to be intuitive in terms of how you trigger automated remediation. This is a perfect example. If I had a good SOAR in place, this alert would have gone out, and we would have been able to start blocking any traffic to and from 10.1 to 195 right away, so we can limit the bleeding. Thanks, Charles. I completely blanked on SOARs, but they are our friends.
It's intentional, because soon, in the coming months, we'll be showing some of our additional work with the Cacao team and ideas of how to expand the course of action STIX object to include those type of workflows, and ways to trigger them and translate them to different platforms is of deep interest to a lot of us here.
Awesome.
So I just also, Robert and Alan, I just want you guys to know that there's a working group every 2 weeks between the Kestrel folks and the OpenC2 technical committee. The OpenC2 is the technical committee that's developing actuator profiles to trigger events. And this working group is aimed at developing an actuator profile for threat hunting. So that may be something you'll want to join.
That's super.
That would be phenomenal.
Yeah, that would be.
I'll connect you with the IBM folks that are running the workshops.
Fantastic.
And if you wouldn't mind, I actually have a second demo that I can show. It's much quicker.
We're gonna
Sure.
run out of time. I think that
We have we can go a little bit longer if you'd
Right.
like.
okay.
So this one is a password spraying recipe. So effectively, what it's doing is on ingest of attempts from logs from an IAM kind of vendor, it is creating in the first standing query a series of these next relationships. So we see here a successful attempt, and you'll see that we are bringing up the temporal relationship. So this attempt happened, then this one happened. So we're doing that dynamically in the standing query, whereas I showed it in a sample query before, and we see that the second query now has a match of some kind. And the story here is a really simple one based on our experience, which is that there was a company that had a contractor that did some work for them, and as is not atypical, they forgot to turn off the contractor account, and you'll see that there were these login attempts that failed one after the other. Now, typically we would depend on fail to ban sort of functionality to look to block the account login if it's within a sliding window. But if you look here, the first is January 2nd, then January 5th, then January 7th, then February 1st. classic password spraying, right? That temporal period is moving. You'll never match those attempts there. But again, this is the value of graphs, and of course, since you're developing Kestrel, clearly you know this, and it's that you're not limited by these temporal windows. Also, we're doing the mapping based on the contractor account and the client being used. Because if we were to expand on the contractor, we would see that they have a ton of perfectly valid logins. And I'll show it to you in a really simple way where I will remove the client and then just have us automatically create this logical vertical mapping. You'll see that here we have one set of next, and then we have a different set of next, and they represent two different clients in use. And actually, probably the better way to show this would be based on the client, but here we go. So you see that this first line here, this is the attack, right? This is the indicator of compromise right here. Fail, 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 succeed. Ah, great. Sell account access. Whereas these are the actual account owner using them. And once in a while, they have a failed login. It happens, a fat finger. And we're not triggering based on the fat finger because this is typical usage pattern, right? So again, with graphs, you can create really complex set of relationships. It's not just this user, they missed their password a certain amount of times. It's they missed it using this client from this source over an extended period of time, so on and so forth. So I just wanted to make that point, which is really important, that we're not temporally constrained.
Excellent. Thank you guys so much for that demo. I didn't mean to cut you off. Did you have some closing
No,
points
that's
you wanted
it.
to say? Okay.
That is it.
So again, wanted to open the floor to some additional questions that people are thinking based on what they saw. And it's okay if you don't have questions right now, but I'll be happy to forward you along if you do have questions later you want to post on the Slack or through the message board. But I just saw somebody pop on their camera, so I'll shut up long enough for them to ask a question if they had one. Nope, that's okay. Just being friendly, and it's appreciated, sir.
I'm with that dot, and I just wanted to, you know, now that my face isn't glued to the screen watching the demo, I decided to pop up.
Oh, glad to have you here.
Also, Charles, I see that Michael Herring had raised his hand.
Oh, Michael, I'm so sorry. I didn't see your hand up.
Michael, you're on mute.
I didn't mean to raise my hand.
Oh,
I don't have a question, but
you were just stretching. It's okay.
okay.
Not a problem, Michael. Okay. So were there any other thoughts or questions? Like I said, I see a few use cases for this, but my brain goes heavily towards the SOAR end for that sounded wrong, but anyway, it came out the wrong way. But anyhow, with that technology. If there aren't any other questions, I will kind of open the floor for general discussion points. Just as a quick matter of logistics, given our meeting cadence, let's see, I believe that, you know, our next scheduled IOB working group will be December 13th at 1 p.m. Eastern time. I know that's getting a little close to the holidays for some folks, but at this point in time, I think we'll still probably try to have it just to close out the year with latest updates and stuff before we all disappear until 2023. But are there any general questions about the IOB working group, some of the previous talks or research, or anything that you saw today? Anybody? I won't force us all here for another 20 minutes. I'm happy to. I can talk very long without taking a breath, but I think for everyone's sanity, I'll see if we have something to talk about, and if not, let everybody get some time back.
I did actually have a question about Quine. Is is it possible to get webhooks generated, or how do you alert from that data?
Great question. And I want to reiterate here that Quine is open source, so you can go to Quine.io, pull it down, play with it, even alter code if you want. When you define a standing query, you define two parts: the pattern match and then the output, which is kind of not perfectly named because it doesn't necessarily have to be output. For example, you can have the standing query actually operate on data. So if you have a match, then increment a counter or set a property or delete a node. But a part of the output includes this and then, and the and then type can be write to Kafka or send to webhook or send to Slack specific webhook because some people are masochists. But that's where it's defined right here, is in the type. What you want the next hop. Let me just do this. I was automating that last demo, but let me show you right here. Embedded in Quine is the API reference, and so for the standing queries, you can, like I said, dynamically create the queries. But if you look at the outputs, you'll see that there's and then that can be included, and we can actually then go specify the output format. So by default, JSON for Kinesis, Kafka, so on and so forth, but you can do a protobuf. But where are you? Here we go. Here is the and then.
Okay.
And so post to webhook, publish to Slack webhook, log JSON to console. That's what I was doing for simplicity's sake. Log to file, Kafka topic, Kinesis, SNS, SQS, or drop. We do have cases where you have a match and you just want to drop the data for data cleansing for ETL purposes.
Gotcha. Nice. I'll have to read through the docs.
Thank you. That's greatly appreciated.
It was our pleasure.
Anybody else? Okay, then. Well, if that's all we have for today, that's what we have. And looking forward to seeing everybody in December. Those that can't make it, catch us on the YouTube channel, and we will see everybody later.
Awesome.
Thanks, everyone.
Take care, everyone.
Bye all.